Right, so in this next problem, this is problem 14-37. A 1200-pound wrecking ball with a velocity of 4 feet per second at the bottom of its arc strikes a wall and comes to rest near a distance of 9 inches. Neglecting any change in elevation of the ball, determine the average force on the wall, the deceleration, and the time period of the deceleration. Okay, so first we're given that the ball weighs 1200 pounds. Okay. And velocity is 4 feet per second. The distance is 9 inches. That's equal to 9 over 12 feet. That's 0.75 feet. Alright, so the way we're going to do this problem is pretty simple. We're going to equate the kinetic energy of the ball to the work done when it strikes the wall. Now, of course, in real world, this is an idealistic problem. You're assuming you're assuming under ideal conditions, but in real world, there are many other factors you have to consider. But anyway, let's go with those assumptions and solve the problem as it is given. Okay, so the kinetic energy is equal to work done. Okay, so half mv square is equal to work done is force times distance. Okay, half mass is 1200 pounds divided by 32.2 weight divided by g. V square is 4 square is equal to, so the force is what we need to find. The distance is 0.75 feet. Okay, so let's see what that comes to. So it comes to 397.5 pounds of force. Now, so this is the first part of the problem. Second part of the problem is asking for deceleration. Find the deceleration. Okay, so here we have the velocity, we have the final velocity, we have the velocity. In this case, it is the initial velocity because once the ball strikes the wall, after that it starts to decelerate. So the initial condition is the velocity of 4 feet per second, and then finally it comes to a halt. So here the u is 4 feet per second, v is 0, s is 0.75 feet. So we use v square minus u square is 2as, right? So 0 square minus 4 square is 2a 0.75. So you get 16.8. So you get about negative 10.67 feet per second square. Right. So what else? So that's the deceleration. And the next is how long does it take for the velocity to change from here to here. So we use our regular formula, v equals u plus at. So v, final velocity is 0, that means it comes to rest. Initial is 4 plus a is negative 10.67 times t. So time comes to 4 divided by 10.67, so that's about 0.375 seconds. Okay.